What would it mean if not the stars, not the galaxies, not even the atoms that compose you and me, but the very stage upon which all of existence unfolds, were to fracture? Imagine the invisible fabric that carries planets in their orbits, that holds together the constellations, that stretches beyond the reach of every telescope ever built. Imagine that this silent backdrop, the thing we casually call space, is not eternal, not stable, but fragile, perhaps even breakable. For centuries, humanity has gazed upward and assumed that whatever happens, whatever bursts or collapses, the void itself will always be there. But what if the void is not truly a void at all? What if space itself can shatter? Close your eyes for a moment and picture an endless frozen lake. Its surface extends beyond the horizon, smooth and flawless, a plane of icy perfection. You step onto it, and at first it feels solid, timeless, indestructible. But deep inside there's a question you cannot ignore. What if beneath your feet cracks already exist? Hairline fractures invisible, until the day they spread with a sound like breaking glass. Space to our ancestors was exactly like that lake, seemingly unchanging, infinite, immune to harm. Yet the more closely scientists observe it, the more it appears less like a flawless sheet of ice, and more like something stretched, stressed, and uncertain. You and I live in a universe where even the empty parts are not truly empty. Space is not the blank silence we were once taught to imagine. It is active, dynamic, restless. It bends in the presence of mass, it swells as time passes, it vibrates with fluctuations too small for the eye. And here is the unsettling truth: if it can bend, if it can swell, if it can ripple, then perhaps it can also rupture. The thought alone is enough to make one pause. Because if space breaks, what does that mean for everything it carries? Scientists are beginning to confront questions that sound less like physics and more like philosophy, or perhaps even nightmares. Can the very arena of reality collapse? Could there be a moment when galaxies fall not because their stars have burned out, but because the space that separates and supports them can no longer hold? We are used to thinking about endings in terms of fire or ice, supernovas, collisions, entropy. But there is another ending whispered about in journals and lectures, an ending where the background itself is torn away. Let's not rush too quickly, though. Take a breath and let this thought settle. Space, the infinite thing you trust, without even noticing it may not be trustworthy. And that realization does not only belong to scientists. It belongs to you too, because whether you are walking beneath the night sky or lying awake in a quiet room, your entire existence unfolds inside this strange, invisible container. To wonder about its fate is to wonder about your own. The history of science is full of moments when humanity thought it had found something solid, only to realize that solidity was an illusion. The Earth felt steady until someone noticed the stars shifted slightly, proving it was spinning. The sun seemed eternal until physics revealed its fuel would one day run dry. Atoms appeared indivisible until they split. Space itself may be the next great illusion we have to outgrow. Like the frozen lake, what feels eternal might only be temporary stability before the crack appears. And here lies the most mind-twisting part. If space is not truly empty but a kind of structure, a flexible, almost fabric-like entity, then it behaves more like a thing than a void. And anything that is a thing can in principle be altered, strained, or even destroyed. A torn cloth cannot hold weight. A shattered glass cannot hold water. If the fabric of reality frays what happens to the stars, the light, the memories, and the fragile threads of thought you are experiencing in this moment, pause here and let yourself feel the weight of that question. We often seek comfort in believing the universe is too vast to care about us, too permanent to notice our brief flickers of life. Yet if the universe is not permanent, if even its scaffolding can collapse, then nothing is too big to fail. It is a humbling, almost terrifying reminder. But it is also strangely beautiful because fragility gives meaning. To exist inside a universe that could one day end is to live inside a story that will one day close its book. That ending makes every page before it shimmer with significance. Scientists do not know if space will fracture tomorrow, a billion years from now, or never. But they are not dismissing the possibility anymore. They model scenarios, they write equations, they test instruments, all while carrying the quiet awareness that the answers may unsettle more than they soothe. And you hearing these whispers may feel a shiver too, as though the ground beneath your feet is less steady than it was a moment ago. That feeling is the first crack of curiosity spreading under the ice. Still, one must be careful. Fear is not the goal here, wonder is. If space itself is breakable, then reality is more alive, more mysterious than we dared to think. The cracks are not only threats, they are invitations to look deeper, to imagine harder, to ask questions no one has asked before. What holds the universe together? What keeps the lake from breaking? And what happens if it does? So now the door stands open. On the other side lies a path of strange theories and unsettling possibilities, each one trying to describe what space is really made of. To follow this path is to step further onto the ice, knowing it might groan beneath you, but also knowing the view stretches wider than anything behind you. And that is where we go next. To understand why space might break, we first need to ask, what is it made of? Einstein did something extraordinary when he reimagined the very emptiness of the universe. Before him, space was thought of as a kind of stage, a hollow container, where the real action took place. Stars burned, planets spun, galaxies collided. But space itself was the silent background, a nothingness with no character of its own. Then came Einstein, and with the sweep of his equations, he transformed that silence into a fabric, a vast cosmic cloth that could stretch, curve, ripple, and warp. The universe was no longer just a play performed on an empty stage. It was a living theatre whose floorboards bent and groaned under the weight of its actors. To understand this shift, imagine a heavy bowling ball placed gently on a taut rubber sheet. The sheet bows downward, and if you roll a smaller ball nearby, it spirals toward the heavy one, not because the balls are reaching out to each other with invisible strings, but because the surface beneath them is bent. Gravity, Einstein said, is not a mysterious force pulling across space. Gravity is space itself, curving. Mass tells space how to bend, and that curvature tells matter how to move. Suddenly, the invisible backdrop was not passive at all. It was a player in the drama, quietly but relentlessly guiding the motion of suns, moons, and falling apples. The power of this image is undeniable. You can almost feel the rubber sheet beneath your hands, see the balls rolling along its dimples and slopes. But here is the puzzle. Is this just a metaphor, a clever way for our minds to picture something otherwise impossible to imagine? Or is space truly like a fabric, something with texture, something that can be stretched and perhaps torn? A metaphor is safe. A real fabric is fragile. If it is only a picture, we can smile and nod and go about our lives. If it is a fabric, then the stakes are different, because fabrics wear thin. When physicists talk about the fabric of space-time, they are not just being poetic. The math of general relativity treats space and time as a single continuous entity, a four-dimensional expanse that responds elastically to energy and mass. Black holes pinch it into funnels. Gravitational waves send shivers through it as they radiate outward from cosmic collisions. Even here on Earth, the ground beneath your feet is embedded in this invisible material, curving just enough to keep the moon circling endlessly above the oceans. We are inside the cloth every second of our lives, though it cannot be touched or seen. For you and me, this raises an unsettling question. If space-time behaves like a fabric, then we must ask what kind of material it is. Rubber sheets fray under stress. Silk can tear with a sudden tug. Even steel cables will snap if too much strain is applied. If the universe itself is woven, then the weaving may not be eternal. There might be threads microscopic and unseen, whose strength determines how long the whole expanse can hold. To live inside such a fabric is to live with the possibility of its unraveling. Take a moment to sit with that thought. Look around your room, the chair beneath you, the walls enclosing you, the sky that will greet you when you step outside. All of it rests within a medium we rarely think about. If it were to give way, if the loom of the cosmos faltered, everything familiar would vanish, not piece by piece, but all at once. It is not just the stars that depend on this hidden cloth. You do too. Einstein's insight was profound, but it left behind mysteries that continue to haunt physics. The equations describe how the fabric curves, yet they say little about what the fabric is. In our everyday lives, materials are made of something, molecules arranged into patterns. Wood is made of cellulose, cloth is made of fibers, glass is made of latticed silica. But what about space-time? What are its fibers? Does it have a weave we simply cannot yet resolve? Or is it in some deeper sense not made of anything at all, a purely mathematical arena conjured by equations rather than built from substance? This uncertainty matters. If space is nothing more than an abstract stage, then the cracks we imagine are merely figures of speech, unsettling but unreal. If it is a true material, however, then like all materials, it might be stressed, stretched, and eventually broken. The cosmic rubber sheet might one day sag beyond repair. The fabric might rip where gravity grows too intense, as near the singularity of a black hole, or where expansion becomes too violent, as in the remote future driven by dark energy. Scientists do not pretend to know the answer yet, but they test it relentlessly. Gravitational wave observatories like LIGO and Virgo have already caught faint tremors in space-time. The tiny stretching and squeezing of the fabric as black holes collide billions of light-years away. Those ripples are real, measurable, and astonishingly delicate. They prove that space-time can vibrate. And if it can vibrate, if it can ripple, then it possesses properties of a medium, and mediums are rarely indestructible. For a long while, people imagined the ocean as infinite and unbreakable, stretching out forever with no edge. Only later did sailors learn of reefs that could tear ships apart, storms that could shatter wood abysses that dropped away into darkness. The cosmic sea may be no different. It looks calm when seen through the telescope, a serene expanse between the stars. But beneath that calm surface, stresses may be building strains, accumulating fractures, forming beyond the reach of our current vision. Think about the implication. A universe where space is vulnerable is a universe where permanence is an illusion. It is a universe where even the stage can collapse, where the play might not only end, but the theater itself be torn to shreds. And you standing in the balcony would not simply lose the show, you would lose the balcony, the air, the time ticking on your watch. There would be nothing left to step outside into because outside itself would be gone. This idea is frightening, yes, but it is also liberating. Fragility invites awe. Knowing the fabric may not last forever makes every moment upon it shine brighter. The stars glitter not as eternal torches, but as sparks caught in a wind that may one day cease. Your breath rising and falling takes place on a stage that is itself finite. That knowledge does not make life smaller, it makes it precious. So the question remains, and it hangs in the air like a note waiting to resolve. Is space-time truly a fabric, or is that only how our minds choose to imagine it? The answer matters because if it is a fabric, then it can rip. And if it can rip, the universe holds within it not just the seeds of stars and galaxies, but the possibility of its own undoing. That thought, unsettling and wondrous, leads us to the next puzzle. If the fabric can tear, then where would the first cracks begin to show? The universe is not still. Beneath the quiet of the night sky, beneath the illusion of stars frozen in their constellations, space itself is pulling apart. The ground under your feet is not steady in the way you imagine. It stretches ever so slightly, moment by moment, carrying you farther away from distant galaxies, separating you from stars you will never see again. It is easy to miss this motion because it happens everywhere at once. There is no wind to feel, no trembling of the earth, no obvious sign. But make no mistake, the cosmos is swelling and you are inside that expansion. The discovery of this unsettling truth came less than a century ago when astronomer Edwin Hubble peered through his telescope and noticed something strange. Light from distant galaxies carried a signature, a redshift, that told him they were racing away. The farther the galaxy, the faster its retreat. This was not the behavior of objects moving through space, as though racing away across some fixed backdrop. This was space itself, stretching, carrying galaxies along like dots painted on the surface of a balloon as it swells. With that realization, the universe shifted from a static picture to a restless, dynamic process. The balloon is the simplest way to picture it. Imagine drawing tiny stars on its surface, then blowing air into it. As the balloon swells, every star drifts farther from every other. No one star is the center yet, each one feels as though all the others are fleeing from it. That is what Hubble's data revealed. And once you see the balloon in your mind, another image follows quickly. One, you cannot avoid what happens if the balloon is blown too far. Anyone who has ever held a piece of latex between their fingers knows the sound, the sudden snap, the point, release of tension. Could space itself share that fate? There is another equally homely image often used, one you may have experienced yourself. Picture a loaf of raisin bread rising in the oven. As the dough expands, the raisins drift apart not because they are moving, but because the dough carries them outward. Left long enough, the bread will grow airy, perhaps even so airy that the surface cracks open, releasing its heat. The loaf can tear when expansion outruns strength. And once you start thinking about cracks, you cannot help but ask whether the universe might behave the same way. This is not just idle curiosity. The expansion of the cosmos is not slowing down. In fact, it is speeding up, driven by a force scientists call dark energy. That acceleration means the fabric of space-time is under more strain today than in the past, and it will be under greater strain tomorrow. The galaxies are rushing apart faster and faster, and if that acceleration continues unchecked, it could push the cosmic fabric beyond its limits. Space might not remain a smooth, unbroken cloth. It could reach a breaking point. Pause here and think about what that means. You are living in a universe that is not simply large, but growing larger at every moment. Every second galaxies slip beyond our reach, carried over a horizon from which their light will never return. The night sky you see now is already thinning. Imagine looking up in some distant future and seeing fewer stars, then fewer still, until only the dim halo of your own galaxy remains. Expansion makes the universe fragile in ways we rarely consider. It carries not only the promise of infinite distances, but the risk of collapse through overstretching. This possibility is more than a poetic image. The mathematics of cosmology contains scenarios where expansion becomes so violent that galaxies cannot remain bound, where solar systems unravel, where even atoms are torn apart as the accelerating pull of space itself exceeds the forces that hold matter together. Expansion that once seemed like a gentle unfolding of creation could become an unstoppable rending. An apocalypse not of fire or ice, but of infinite stretching. Scientists call such an outcome a big rip, and though no one knows for certain if it awaits us, the idea lingers like a shadow on the edge of physics. It is not hard to feel a chill when contemplating this. We are used to thinking of death on the small scale, our own, or that of a star burning out. But to imagine the death of space itself through expansion is to step outside the comfort of permanence. If space can rip apart, then nothing, not galaxies, not atoms, not even the ticking of time would remain. And yet there is a quiet beauty in recognizing this fragility. The stars overhead become more precious when you realize they may not always shine together in the same firmament. Your life, brief as it is, unfolds inside a cosmic drama of expansion whose final act is unknown. The cracks of expansion, then, are not just physics. They are invitations to wonder. They tell us that the universe is not a finished thing, but a story still unfolding with pages yet to be written, perhaps with an ending more dramatic than anything we can imagine. And as unsettling as that ending might be, it connects us more deeply to the mystery of existence. We are not passive passengers, but witnesses to a universe that changes at the most fundamental level, carrying us along in its restless tide. So here we stand, balanced on a fabric that stretches beneath us, pulled outward by a force no one fully understands, watching the galaxies drift away. We do not know how long the fabric can hold. We do not know whether it will tear like an overinflated balloon or rise like dough forever without breaking. What we do know is that expansion cannot be ignored. It is the silent process reshaping reality second by second beneath our very feet. And with that thought comes the next inevitable question. If expansion can lead to rupture, if the cosmic fabric can be torn, what does that rupture look like? What shape does the breaking of space take? That is where the journey leads now into one of the most haunting and terrifying possibilities ever proposed by science. What happens when the universe dies, not by collapse, but by being ripped apart? Imagine a day when the universe itself betrays everything it holds. Galaxies drift apart, not slowly, not gently, but violently, pulled away from one another, as though some invisible hand has decided to rip the very canvas of existence. The stars that once bound galaxies together, the planets orbiting their suns, even the bonds that hold atoms intact, all of them are stretched beyond recognition until they snap. This is not a scene from science fiction. It is the unsettling vision known as the Big Rip, a scenario that whispers of an ending stranger and more terrifying than fire or collapse. The Big Rip begins innocently enough with the very expansion you already live within. Space is stretching and galaxies are slipping away. But imagine that this expansion does not simply continue at the same pace. Imagine it accelerates, feeding on a mysterious energy that refuses to diminish. Over billions of years, the acceleration grows stronger, tugging harder on the fabric of space-time, until no structure, no matter how vast or small, can resist. What starts with galaxies separating ends with the disintegration of everything familiar. At first, the effects would be distant and almost imperceptible. Galaxies far from us would vanish beyond the cosmic horizon, their light unable to cross the ever-expanding gulf. Over time, however, the pull would reach closer. Our own galaxy, the Milky Way, would no longer be able to cling together. Stars bound for billions of years by their mutual gravity would be wrenched apart, scattered into the void. In this stage of the story, the universe would already look alien to any observer, a sky thinning into emptiness. But the process would not stop there. Expansion, relentless and accelerating, would next unravel solar systems. Planets could no longer circle their suns, the bonds of gravity stretched too far. Earth itself would be set adrift, torn from the embrace of its star. To imagine this is to picture the oceans suddenly frozen without sunlight, forests withering, the last breath of a planet swallowed by cold space. Yet even this is not the end. As the pull intensifies, planets themselves would come apart. Mountains, oceans, continents, everything we know as solid and enduring would fracture under the stress of expansion. You might imagine standing on Earth in such a moment, feeling the ground no longer steady but tugged in all directions at once. A planet that has held together for billions of years would crumble like dry clay. Humanity, if it still exists, would witness a world dissolving beneath its feet. Still, the tearing does not stop. The Big Rip reaches into matter itself, into the bonds of molecules and atoms. The forces that bind protons and electrons, normally so strong, would falter under the strain. In the final moments, the very particles that form your body, your thoughts, your memories, would be pulled apart. The Big Rip does not leave ruins behind. It erases structure at every level until nothing remains but an unimaginable thinness, a universe stretched past the possibility of coherence. This scenario is not just a poetic thought experiment. It follows directly from certain models of dark energy, the mysterious pressure driving cosmic expansion. If dark energy grows stronger with time rather than staying constant, then acceleration would not simply carry galaxies away, but eventually destroy all binding forces. The timeline depends on the properties of this energy. Some versions predict a universe lasting trillions of years before unraveling. Others offer a future much closer, measured in mere billions. Either way, the Big Rip hangs as a possibility, like a shadow at the edge of cosmology's equations. Scientists wrestle with this vision because it challenges the very idea of permanence. We have long understood that stars die, galaxies evolve, and planets shift. But to imagine the entire framework of reality dismantling itself is another matter entirely. The Big Rip says that no fortress is safe, not gravity, not electromagnetism, not even the strong nuclear force at the heart of atoms. It is the ultimate betrayal. the very space that holds everything together, becomes the thing that tears it all apart. You may feel a chill reading this, and perhaps you should. The Big Rip is not the kind of ending that allows survivors or witnesses. There is no one left to tell the story. Yet there is also something strangely awe-inspiring about it. If this is how the universe ends, then existence itself becomes the brief flare of structure in an ocean destined to flatten into nothing. In that light, every moment becomes more precious, every connection more fragile, every glance at the stars more urgent. Take a moment to breathe in that thought. Imagine your life not as an isolated story, but as a flicker inside a cosmic drama rushing toward an unknown finale. Whether or not the Big Rip will truly come, the idea itself invites us to consider how we value the present. If the universe can unravel at every level, then what you hold in your hands today, love, knowledge, memory, is infinitely rare. For scientists, the Big Rip is not only a nightmare but a motivation. It pushes them to understand dark energy more deeply, to measure its properties with greater precision, to determine whether its strength is stable, weakening, or growing. The stakes are as high as science can imagine, for the fate of all structure lies in the answer. And until that answer is known, the possibility lingers. Somewhere in the equations, somewhere in the future, there may be a line of destiny pointing toward a universe that stretches itself into oblivion. Yet before surrendering to this vision of cosmic annihilation, there is another question worth asking. If the Big Rip depends on dark energy, then what exactly is dark energy? What is this invisible force that accelerates expansion that may one day decide the fate of every atom? To confront the Big Rip is to confront its source. And so the story must turn toward that mystery, toward the strange shadow haunting the cosmos, toward the thing we call dark energy. 95% of the universe is made of something no one has ever touched, tasted, or even directly seen. That sentence alone should be enough to stop anyone mid-thought. Almost everything that feels solid or visible, stars, planets, your body, the chair you are sitting on, is part of the small remainder, a sliver of reality that clings to the edges of an ocean of the unknown. The rest, the overwhelming majority, hides in shadows. And at the heart of that mystery is something called dark energy, a ghostly presence that may hold the fate of the cosmos in its grip. When scientists first proposed its existence, it sounded like an afterthought, a patch to cover a gap in the equations. The universe was expanding, yes, but not in the way anyone expected. Galaxies weren't just drifting apart under the lingering momentum of the Big Bang. They were accelerating as though pushed by an invisible hand. That hand, by all measurements, had no glow, no particles to announce itself, no interactions with matter in the ways physicists usually recognize. It was like being shoved in the dark by something you could not see or touch. To account for it, scientists gave it a name not because they understood it, but because they had to call it something: dark energy. Dark energy is unlike anything else in physics. It doesn't cluster like matter. It doesn't shine like radiation. It doesn't seem to obey the rules of ordinary forces. Instead, it works quietly, uniformly across the vast expanse of space, driving every corner of the cosmos outward. Its effect is so pervasive that it accounts for nearly 70% of the universe's total content, with dark matter making up most of the rest. Ordinary matter, the kind you and I are made of, is almost negligible by comparison. To grasp this is to realize that what we call the visible universe is just the foam on the surface of an unimaginably deep sea. If dark energy is stable, if it simply remains what it is, then the universe may expand forever, galaxies drifting into solitude until no light can reach another. But if dark energy evolves over time, if its strength grows or weakens, then the fate of everything changes. It is here in this uncertainty that cosmologists encounter their deepest anxieties. For if dark energy grows stronger, it leads to scenarios like the Big Rip tearing apart galaxies, stars, planets, and atoms. If it weakens, the expansion may slow and reverse, pulling the universe back into a catastrophic collapse known as the Big Crunch. And if it shifts unpredictably, morphing into something new, then reality could transform in ways no one has words to describe. The most unsettling part is that no one knows what dark energy truly is. Some theorists suggest it may be a property of space itself, an energy woven into the very fabric of the cosmos. Others suspect it is a kind of field that pervades the universe, one that could decay or fluctuate, perhaps even vanish altogether. There are whispers in the equations that dark energy might be connected to quantum mechanics, to the restless jitter of particles in the vacuum. And yet when physicists try to calculate its expected strength, they arrive at numbers so absurdly wrong off by more than 100 orders of magnitude that it remains one of the most embarrassing puzzles in modern science. Imagine standing under a night sky filled with stars. Every point of light you see, every galaxy beyond it, is a reminder of how little we truly know. You gaze upward and believe you are looking at reality, at the totality of existence. But the truth is that you are staring at the exceptions, at the leftovers. The main act of the universe is invisible, and it is this invisible stagehand that pushes galaxies away, deciding whether the story of the cosmos ends in expansion collapse or something even stranger. What makes dark energy feel like a ghost is its silence. It does not speak through light. It does not betray itself in collisions. It does not bend or break in experiments. We know it only through its effect on the grandest scales, through the way space itself stretches. That silence gives it an almost mythic quality, as if the universe were hiding its most important truth just out of reach. You can sense its presence only by looking at what it does, not at what it is. In that sense, dark energy is more like a shadow on the wall than an object in the room, a negative space that defines reality by what it erases. And yet within that silence lies power. If dark energy changes, everything changes. The stars may fade faster or linger longer. The cosmic web may unravel or tighten. Even the geometry of space-time, the shape of reality itself, may warp into forms our imagination can barely hold. We are not speaking about small details here, but about the destiny of everything. In the end, the question of what dark energy is becomes the question of what the universe is allowed to become. For you sitting here in this moment, the idea can feel both impossibly distant and strangely intimate. It might seem absurd to worry about a force that acts across billions of light years, stretching galaxies far beyond what human eyes will ever see. Yet that force is also acting beneath your feet, between the atoms of your body, threading through the very space that holds you together. You are part of a reality in motion, swept along by a current that has no name beyond dark energy. To realize this is to feel both small and connected, fragile and extraordinary. Scientists chase this mystery not only because they want to predict the fate of the cosmos, but because they want to understand what reality truly is. If dark energy is a property of space, then space is not a passive stage, but an active participant. If it is a field, then new physics may lie waiting to be uncovered. If it is something else entirely, then our current theories may be just the first draft of a much larger truth. Each telescope scanning the sky, each satellite measuring the faint glow of ancient light, is part of a collective attempt to catch this ghost in the act. But for all its enormity, dark energy is not the only threat to the stability of space. Expansion is not the only way the fabric of reality can fail. There are other possibilities, other cracks waiting to be imagined. Other scenarios where space itself unravels in ways that defy even the boldest of theories. Dark energy may be the most famous suspect in this cosmic mystery, but it is not alone. The universe, vast and unpredictable, has more than one way to break itself. And so the story continues as we turn from this ghostly energy to the other paths by which space might one day shatter. At the grandest scales, space feels calm, steady, and almost eternal. Stars drift in vast arcs, galaxies spin like silent wheels, and the cosmic background hums with faint, ancient light. But if you zoom in far enough, if you strip reality down to its tiniest building blocks, the calm vanishes. Beneath the stillness of the night sky, there is chaos. At the smallest scales that quantum physics allows, space itself is not empty at all. It seethes, bubbles, and churns like a pot of boiling water left on the stove. This picture comes from the strange marriage of relativity and quantum theory, where nothingness is never truly nothing. In the quantum view, a vacuum is not a barren void, but a restless sea. Particles and antiparticles flicker into existence, collide, and vanish again, their presence, so fleeting that no one can ever hold them in their hand. These brief visitors are called virtual particles, and their activity is known as quantum foam. Imagine space not as a smooth fabric stretched flat, but as a frothy, uneven surface where waves of possibility rise and collapse endlessly. The term foam is not just poetic. It captures the sense that reality at its foundations is jagged and unstable. Where classical physics paints a picture of order, quantum physics insists that randomness is built into the structure itself. These fluctuations are tiny, so small that under ordinary circumstances they pass unnoticed. But they are not trivial. Their presence can shift the behavior of particles, influence the energy of fields, and even alter the way light bends around massive objects. Every moment, every corner of the universe is alive with this bubbling, invisible activity. This means that the very ground we imagine as solid, the fabric of space and time, is not solid at all. It is stitched together by probabilities full of holes and bursts, as fragile as sea foam on a wave. To walk across space, even just by sitting still in your chair, is to trust in a surface that is constantly forming and reforming beneath you. The fact that the universe appears stable at all is something of a miracle, a testament to the way these countless fluctuations average out to a calm that feels to our human senses like permanence. And yet permanence is an illusion. For every bubble that flickers into being, there is the possibility of disruption. The froth of quantum foam is not merely decorative, it is energetic, unpredictable, and deeply tied to the fate of the universe. When physicists speak about the fragility of reality, they often point here to this seething background that underlies everything. It is as though the universe rests on an ocean of stormy waters we cannot see but that never truly sleep. If you pause for a moment and imagine this, it becomes unsettling. You and I are used to thinking of the world as solid and stable. The table in front of you, the floor beneath your feet, the air filling your lungs, these things feel unshakable. But they are built on emptiness that is not empty on a background that is in constant flux. What appears smooth and continuous is at its most basic level jittery and restless. You are living in the eye of a storm carried along by patterns of emergence and disappearance that never stop. The consequences of this go beyond poetic imagery. Quantum fluctuations have been woven into the history of the cosmos itself. In the earliest moments after the Big Bang, it was the tiny random jitters of quantum foam that seeded the first clumps of matter. Those clumps grew into galaxies, into stars, and eventually into planets like Earth. Without the turbulence of the foam, there may have been no structure at all, only a featureless expanse of energy. In a strange twist, the same bubbling that makes reality fragile is also what made existence possible. But there is a darker side to this story. If fluctuations can nudge the growth of galaxies, what else might they do? Theorists have warned of scenarios in which a single bubble of quantum foam might trigger a runaway effect, one that destabilizes the vacuum itself. In this nightmare version of physics, a fluctuation could spark the formation of a new kind of space, a lower energy vacuum that expands at the speed of light. If such a bubble appeared, it would rewrite the laws of reality as it spread, consuming everything in its path. One instant, you might be reading this sentence, and in the next space itself would dissolve around you. This possibility is known as vacuum decay, and while it remains only a theoretical idea, it illustrates the precariousness of building a universe on quantum foam. The very thing that underlies all stability may also contain the seeds of annihilation. To say that this idea keeps some physicists awake at night would not be an exaggeration. Even if the odds are minuscule, the scale of the consequence total erasure makes it impossible to dismiss completely. For those of us outside the laboratory, it is tempting to treat such scenarios as science fiction. And in a way, they are, at least for now. The timescales involved are so vast, the energies required so unimaginable, that it is not something we need to fear when we wake in the morning. But at the same time, there is something deeply humbling in knowing that the universe itself may be more fragile than we imagine. that the ground beneath all existence is not concrete but foam, that everything we hold dear depends on fluctuations we cannot control. If you let yourself sit with that thought, you begin to see the world differently. The stars above are not only distant fires, but also products of chance, born from the frothing of a quantum sea. The atoms in your body are not only stable matter, but echoes of fluctuations that never rest. You are not separate from the foam. You are a pattern it produced, one ripple among countless ripples in a cosmic storm. Some people find comfort in this, others find dread. Perhaps you feel a little of both. But one thing is certain, the picture of reality that emerges from quantum physics is far stranger than anything our ancestors ever imagined. The ancients saw the universe as a dome, steady and eternal. We now know it is more like a bubbling cauldron, where even space itself is alive with motion. And here is where the story sharpens. Fragile, yes, but fragility can become danger. For in the boiling sea of quantum foam, there lurks the possibility of collapse of chain reactions that reshape everything in an instant. If the vacuum is not as stable as it seems, if one bubble can trigger a cascade, then space may not simply endure forever. It may end, not with a slow fading, but with a sudden and silent transformation. This thought may feel distant now, a puzzle for physicists to scribble in their equations. Yet it is also a reminder of the delicate balance that holds the cosmos together. The boiling never stops, and neither does our search for meaning within it. The universe beneath its calm face is restless, and in that restlessness lies both creation and destruction. The foam whispers that reality is temporary, that permanence is only a mask, and that the story of space may yet take a turn no one expects. What if the reality you and I take for granted is not the final version of reality at all? Imagine that everything around you, from the glow of the stars to the atoms in your body, is balanced delicately on a surface that only seems stable. In physics, this idea is captured by a theory known as vacuum metastability. It suggests that our universe may not be resting in the lowest possible state of energy, but rather in a false vacuum, a temporary plateau in the landscape of existence. To picture it, imagine a ball sitting in a shallow valley. From the ball's perspective, it feels secure, tucked away in a dip where it will roll back if nudged. But higher up the mountain lies a deeper valley, one that represents a more stable, lower energy state. If the ball ever crosses the ridge, gravity will pull it down into that deeper valley. In the same way, our universe may not be in its absolute lowest state of energy. It may be balanced in a false one, appearing calm, while always harboring the possibility of collapse. At first glance, this sounds like abstract mathematics, an idea confined to chalkboards and computer simulations. But its consequences are anything but abstract. If a transition to a true vacuum were ever triggered, the result would be a bubble of new space forming somewhere in the universe. That bubble would not expand slowly like a balloon you inflate by hand, but at the speed of light. It would sweep through the cosmos, erasing the false vacuum and everything in it. Within its boundary, the laws of physics as we know them would no longer apply. Molecules, atoms, even the forces that hold particles together might dissolve into unfamiliar forms. What makes this scenario so chilling is the absolute silence with which it would arrive. There would be no warning, no rumbling of distant galaxies, no flicker in the sky. One moment, life would go on as usual, you reading these words, me writing them, stars burning, planets spinning. The next, the bubble would pass through and reality as we know it would vanish. Because it spreads at the speed of light, no signal could outrun it, no telescope could glimpse its approach. There is no escape, no preparation, only sudden transformation. For scientists, the idea is not so much a prophecy as a possibility. The mathematics of particle physics, particularly the behavior of the Higgs field, discovered in 2012, leaves room for this metastable state. Some models of the Higgs potential suggest that our universe is perched precariously stable enough for billions of years, but not guaranteed to endure forever. Others suggest we are safe the ball securely in the deepest valley already. The truth remains uncertain, and in that uncertainty lies both fascination and fear. You might wonder why anyone would spend their life contemplating such a grim possibility. But here's the twist. Thinking about vacuum metastability is not just about predicting doom, it's about probing the very foundations of physics. If the vacuum is false, then what lies beneath it? Is there a deeper structure of space-time, one we cannot yet see, waiting to be revealed? Could the laws we consider fixed gravity, electromagnetism, the nuclear forces be just temporary, scaffolding destined to collapse into something new? These questions strike at the core of what it means to understand reality. Pause here and consider it personally. You live each day with the quiet assumption that the ground beneath your feet is real, that space and time are permanent backdrops. But what if that permanence is an illusion? What if everything we know exists only as long as the vacuum remains metastable? It is a humbling thought. We do not simply live within the universe, we live within a state of the universe, one that might not last. Of course, before despair takes hold, it is worth remembering that this fragility is theoretical and perhaps distant beyond comprehension. Even if the universe is metastable, the timescales involved may dwarf the lifespan of stars, galaxies, or any beings who might worry about it. We are not talking about decades or centuries, but spans so vast they bend language itself numbers of years greater than the number of atoms in the observable universe. And yet there is no law preventing the transition from happening sooner. That paradox, utter remoteness, paired with sudden immediacy, is what makes the idea so haunting. In many ways, vacuum metastability is less about fear and more about perspective. It reminds us that the laws of physics are not carved into stone tablets, but written into fields and particles that themselves might change. It suggests that the universe is not a finished structure, but a work in progress, one phase in a larger hidden story. If there is a true vacuum beyond our false one, what might it be like? Could it give rise to a new kind of universe governed by rules so alien we cannot imagine them? Or would it be sterile, empty, devoid of the complexity that allowed stars, life and thought to arise? When faced with such possibilities, you and I are left with a choice in how to respond. We can treat the idea as a source of dread, a reminder that existence may be fleeting, or we can treat it as a source of wonder, a reminder that reality is deeper than we know, that there are still mysteries vast enough to humble even the most brilliant minds. To imagine a false vacuum is to admit that our understanding is incomplete, and in that incompleteness lies the excitement of discovery. So yes, the thought of a bubble of annihilation sweeping silently across the cosmos is unsettling, but the thought that space itself still hides layers we have not touched, that the vacuum beneath our feet is only a mask, should inspire awe. It means there is more to reality than meets the eye. It means that even now, with all our science and telescopes and theories, we are still scratching the surface of what existence truly is. The possibility of metastability does not close the story of the universe, it deepens it. It hints that there may be other states of being, other forms of space-time waiting in the wings. If we are fortunate, we may never witness such a transition. But by imagining it, by confronting the fragility of what we call real, we push closer to the heart of the cosmic mystery. And that is where the story leads us next. Fragile as it may be, this scenario is not the end of the conversation. In fact, it opens the door to even greater questions. If our vacuum is false, if we are living in a temporary state, then what lies beyond? Does space have hidden layers, deeper structures that we have yet to glimpse? The very possibility invites us to look further, to admit that reality may be more intricate than we have ever dared to believe. Imagine for a moment that everything you see, touch, and know is the echo of a hidden vibration, that the atoms forming your body, the stars stretching across the night sky, and even the light streaming from distant galaxies are all resonances of tiny invisible strings. This is the vision proposed by string theory, one of the most audacious ideas in modern physics. In this framework, the universe is not a collection of point-like particles, but a symphony of oscillating strings, each one vibrating at its own frequency, creating the particles and forces we observe. What we perceive as matter is merely the result of these infinitesimal strings, dancing across the fabric of existence. String theory stretches the imagination because it asks us to see space itself differently. Rather than being a passive stage on which matter acts, space may be a dynamic participant. Some versions of the theory propose membranes or branes as higher dimensional surfaces on which these strings live. Our familiar three-dimensional space might be one such membrane floating in a higher dimensional realm. And just as a drumhead vibrates when struck, these membranes can ripple, fold, and oscillate, producing the physical phenomena we perceive as forces and particles. The universe in this picture is both instrument and symphony, a vast musical instrument vibrating in dimensions beyond our senses. Now consider what that means for the stability of reality. If the fundamental constituents of matter are strings, then the fabric of space is intimately tied to their integrity. Break a string, and the particle it produces vanishes. Rip a membrane, and the three-dimensional universe we know could deform or fragment. The cracks, rifts, or distortions that cosmologists fear might not be limited to abstract mathematical models. They could correspond to actual fractures in the cosmic strings or branes underpinning existence. Space tearing apart is no longer metaphorical. It could signify the snapping of the threads that weave reality together. The implications of this perspective are staggering. When physicists calculate how strings vibrate, they find a universe full of possibilities, each vibration producing a slightly different particle or force. The familiar particles of the Standard Model, the electrons, quarks, photons, neutrinos, are just a tiny subset of an enormous spectrum. And because these strings exist in multiple dimensions, many of which we cannot perceive, the universe may contain hidden structures whose behavior could influence the observable cosmos in subtle, profound ways. A small perturbation in one of these hidden dimensions could manifest as a catastrophic instability in the three dimensions we inhabit. To picture this more tangibly, imagine a spider web stretching across a room. Each strand is under tension, transmitting vibrations across the entire structure. Pluck a strand, and ripples move through the web. Now imagine that some strands are so thin, so tightly interwoven, that a small tear could propagate uncontrollably, distorting or severing large sections of the web. This is not mere metaphor, it mirrors the delicate interdependence of strings and branes in the universe. The music of existence depends on their integrity. If the music stops, so does the structure we call reality. And yet, for all its fragility, this picture is not purely catastrophic. The vibrational nature of strings allows for a rich, dynamic cosmos. It offers explanations for phenomena that otherwise baffle physicists, from the relative strengths of fundamental forces to the properties of black holes. It suggests that the universe is far more harmonious than random, that hidden patterns govern the chaos we observe. In some sense, the fabric of reality is both resilient and delicate, capable of producing astonishing complexity while being sensitive to disturbances on scales smaller than an atom. Consider, too, the philosophical resonance. If strings and branes underpin everything, then reality is at once more intricate and more unified than our senses suggest. What we perceive as space and matter is merely the surface of a deeper order, a set of harmonics in a cosmic orchestra. The cracks in space, the possible rifts and instabilities, are analogous to dissonances in a symphony, moments when the music threatens to falter. And just as a skilled musician must attend to subtle vibrations to maintain harmony, the universe maintains its coherence through these interwoven strings. But there is a paradox in this music. The very vibrations that produce particles and forces also carry the potential for silence. If a fundamental string were severed, if a membrane tore, the resulting disruption could cascade through the fabric of reality. Forces might vanish, particles dissolve, and even the geometry of space could be altered. The universe might experience what physicists call a topological catastrophe, a sudden rearrangement of dimensions and connections that would fundamentally change or even erase the reality we inhabit. The harmony that sustains matter is not guaranteed. It is contingent on the continuity of these strings and membranes. Pause for a moment and reflect on that. Every photon that enters your eye, every heartbeat, every motion of your hands is part of a cosmic performance, dependent on vibrations invisible to your senses. You exist because strings resonate at precisely the right frequencies. And yet the same vibrations that sustain life and matter also hint at fragility, at the possibility that a subtle disturbance could reverberate across scales far larger than a human lifetime, far larger than galaxies. The music of the cosmos is both creation and warning, a reminder that existence is contingent and miraculous. This framework also suggests new ways of thinking about cosmological rifts. When cosmologists discuss space tearing, they might be speaking not merely metaphorically, but about real disruptions in the network of strings and brains. Expansion, dark energy, quantum foam, false vacuums, all these phenomena could be interpreted through the lens of string theory as tensions in the fundamental structure, oscillations that might overstrain the cosmic web. If true, the very act of observing or interacting with the universe is like plucking a string, sending vibrations through the hidden layers beneath the surface of reality. The picture is simultaneously awe-inspiring and unnerving. To live in a universe where the foundational level is vibrating strings and hidden membranes is to exist inside a complex, dynamic, and fragile musical instrument. It is to participate in a performance whose score we cannot read, whose notes we can hear only faintly, and whose conductor remains invisible. And in that awareness lies both humility and wonder. We are not masters of this cosmos. We are attentive listeners, participants in a music that began long before us and will continue long after. Finally, imagine what this means for the extremes of reality, the ruptures and crises that physicists speculate about. If strings snap or membranes tear, space could fracture in ways more profound than any collapse or expansion. These are not just dramatic visions, they are logical consequences of a universe built on oscillations. The smallest vibration carries the seed of the largest catastrophe. In other words, the music of the cosmos is inseparable from its fragility. And in contemplating that music, we begin to glimpse both the beauty and danger encoded in the very fabric of existence. And so the story moves forward from the strings that sing to the silent notes that warn. If space can be a web of vibrating strings, and if those vibrations sustain all we see, then the question arises, what is the next level down the deeper architecture that supports even these strings? Could there be structures beneath the process, vibrations themselves, hidden frameworks that define the potential for both creation and destruction? The universe, it seems, may have layers. We are only beginning to imagine, waiting to reveal themselves as we peer ever closer into the fabric of reality. Imagine that the universe you inhabit, the one that seems so vast and immutable, is but a single page in a much larger cosmic manuscript. The idea is dizzying, and yet it is the natural implication of theories proposing a multiverse, a reality in which our familiar three-dimensional space is just one of countless brains floating in higher dimensions. In this vision, what we call space is not the totality of existence, but a single membrane, a delicate layer in a vast stack of unseen realms. Each brain could host its own universe, with its own stars, planets, and perhaps even life entirely separate from ours, yet intertwined in ways that challenge our understanding of reality itself. The notion of multiple brains stems from string theory and its higher dimensional extensions. While we experience the universe in three spatial dimensions, and one of time, the mathematics permits more dimensions compactified or hidden from ordinary perception. Our brain then is a three-dimensional sheet embedded in this higher dimensional space, drifting alongside other brains like pages in a book. And just as pages can touch, collide, or fold against one another, so too could these brains interact in the higher dimensional expanse, producing consequences far beyond our immediate observation. One of the most fascinating implications of brain interactions is the potential explanation for the Big Bang. In certain models, our universe could have originated from a collision between two brains. The immense energy released in such a cosmic impact would have created the hot, dense state from which our universe expanded. In other words, the birth of everything we see might be the result of a delicate higher dimensional dance, a near miss between enormous sheets of space. But if collisions can give rise to creation, they could also produce destruction. The same forces that once sparked the Big Bang could in principle destabilize a brain, tear it apart, or dissolve it into the higher dimensional bulk. This perspective reshapes our understanding of cosmic fragility. The cracks and rifts physicists worry about might not only be internal to our three-dimensional space, but could reflect disturbances in the higher dimensional environment. A fracture in our brain might not look like a conventional tear. It might appear as a sudden dissolution, a slipping away into dimensions beyond our perception. If space can dissolve into a higher dimensional bulk, the end of our universe might not be an explosion, a freeze, or a collapse, but a gentle unspooling into something larger, a disappearance into a context we cannot imagine. The multiverse concept also invites reflection on probability and contingency. In a vast stack of brains, countless variations of reality could exist simultaneously. In some brains, the physical constants might differ. Stars might never ignite, planets may never coalesce, or life may emerge in forms utterly alien to our expectations. Our universe, with its precise conditions for galaxies, chemistry, and life, may be just one favorable configuration among an infinity of possibilities. And if the higher dimensional brain landscape is dynamic, then the stability of any one brain, including ours, is always contingent, always provisional, always dependent on interactions we cannot see. To appreciate the scale of this possibility, consider the cosmic horizon you can see in the night sky. Beyond those distant galaxies, the observable universe ends, and what lies beyond is hidden, perhaps unknowable. In the brain picture, beyond that horizon could be entirely separate. Universes, their light never reaching us, their physics potentially alien, their histories and futures unfolding in parallel. Our own experience, our lives, our history might be just a single thread in a tapestry far larger than the mind can grasp. And the stability of that thread may hinge on interactions we cannot detect, ripples in the higher dimensional sea we inhabit unknowingly. There is also an intimate philosophical resonance here. To live in a multiverse of brains is to realize that the cosmos is neither singular nor absolute. What you see is not everything. What you know is not the totality of being. The universe is layered, complex, and potentially infinite in its variety. This invites a profound humility, a recognition that our notions of permanence, centrality, and significance are limited by the scale and structure of reality. Yet it also sparks wonder, a sense that existence is richer, deeper, and more mysterious than we have dared imagine. If two brains collide, it may be catastrophic, producing energies beyond comprehension. But even subtle interactions could propagate instabilities, subtle ripples that accumulate over eons, threatening the coherence of our own membrane. A crack in our brain might not tear galaxies apart immediately nor annihilate atoms, but it could create distortions in the laws of physics, local instabilities that slowly expand, altering the cosmic landscape in unpredictable ways. The end of space might not be abrupt. It could be a slow, inexorable dissolution into the higher dimensional void. And yet the multiverse perspective also offers hope, or at least perspective. If our brain is fragile, it is only one among countless others. Creation and destruction are not unique events, but ongoing processes, part of a larger rhythm beyond comprehension. Just as individual waves rise and fall on the ocean, individual brains may emerge, evolve, collide, or vanish, each contributing to a larger structure of reality. In this sense, even the loss of one universe is not absolute annihilation. It is part of a broader pattern, a cosmic cycle playing out across dimensions beyond sight or measure. Pause and imagine for a moment you, a tiny conscious observer, sitting on one brain, reading these words, living a life of choices and experiences, unaware that entire universes might drift above, below, or alongside you. The cosmos is far larger and stranger than we can perceive. What feels infinite and absolute may in truth be just one membrane, in a higher dimensional expanse, one page in a book whose authors we cannot know, whose narrative may extend beyond the bounds of comprehension. This raises profound questions. If space is layered, if universes exist in parallel, then who or what, if anything, orchestrates this cosmic manuscript? Is there a principle or law governing brain interactions? Or is the multiverse a self-organizing ensemble without purpose or direction? The idea challenges our deepest intuitions, forcing us to consider that causality, order, and even time might operate differently beyond our familiar dimensions. The multiverse does not just expand the scale of reality, it transforms the very questions we ask about it. In the end, contemplating brains and parallel universes is both humbling and exhilarating. It reminds us that fragility and stability coexist, that creation and destruction are woven into the same higher dimensional fabric, and that the universe we inhabit is only a part of a much greater whole. What we perceive as the totality may be only a chapter in an endlessly unfolding narrative, one that hints at mysteries we may never fully grasp yet, which invite us to imagine, to explore, and to wonder. And as we turn our gaze from layers of space to the question of authorship itself, we confront the most profound mystery yet. If the universe is a book, and we inhabit a single page, then who or what is writing it? What principal force or structure determines the form and fate of these brains, and by extension, the reality we experience? The question may lie beyond physics, philosophy, or even imagination, yet it is the natural continuation of every step we have taken into the depths of cosmic fragility and structure. Time and space are more intimately intertwined than our everyday experience lets us sense. We walk through rooms, watch clocks tick, and perceive a steady passage of events, but this apparent flow is inseparable from the spatial framework that supports it. In Einstein's revolutionary view, space and time are not separate arenas. They are woven together into a four-dimensional fabric called space-time. Every motion, every gravitational pull, every photon traveling across the cosmos is a journey through this unified continuum. What this means quietly yet profoundly is that if the fabric of space were to fracture, dissolve, or vanish, the flow of time itself would be imperiled. To imagine the consequences, picture a skein of yarn. Each thread represents a line of time tightly wound together to form the continuity we experience. Space is the material that holds the threads in alignment, the structure that lets us perceive cause and effect. Now imagine cutting through the yarn at an angle, slicing the fibers apart. The threads unravel, their alignment destroyed, leaving a tangle of disconnected filaments. In this analogy, ripping the spatial fabric doesn't merely displace matter or energy, it destabilizes the temporal sequence itself. Time might not simply run backward or forward. It could cease in regions where space no longer holds. The implications of this are both subtle and terrifying. We often conceive of the end of the universe in dramatic terms, stars burning out, galaxies, collapsing black holes evaporating. But if space itself ceases to exist, the universe does not end in the conventional sense. There is no fire, no explosion, no slow fade into darkness. Instead, there is a halt, a cessation of events, a suspension of reality, in which past, present, and future lose meaning. The very notion of an endpoint changes. It is not destruction, but an ultimate standstill, a pause so absolute that the concept of duration becomes irrelevant. This idea reshapes our understanding of causality. In a universe governed by unbroken space-time, causes lead to effects, events unfold in predictable sequences, and history leaves a trail for observers to trace. But if the fabric of space tears, these links may vanish. The past may remain as memory or record, if anything survives to perceive it, but the future ceases to form. There is no continuity, no progression, only a frozen moment in which the machinery of existence grinds to a stop. For any observer embedded in such a reality, the experience might be beyond comprehension. There is no later, no ticking of clocks, no unfolding of events, just an eternal, unchanging stillness. The analogy of yarn can be extended. Each thread is not independent. Cutting one can loosen others, creating cascades of disconnection. In the cosmic context, a local fracture in space might propagate, destabilizing nearby regions and eventually affecting entire cosmic structures. The interconnectedness of space-time means that disruption is not contained. A rift in one area could resonate outward, unraveling the temporal sequence across vast distances. This is not a speculative metaphor. It is the natural extrapolation of what physicists call the inseparability of space and time. They are two sides of the same coin. If one fails, the other cannot continue alone. To ponder this is to confront the ultimate fragility of existence. Our lives, our histories, even the universe itself are contingent on the continuity of a medium we cannot see or touch. Every heartbeat, every thought, every photon streaming across the cosmos relies on the integrity of space-time. And yet the very things that seem eternal, the vast stretches of interstellar void, the relentless march of time may be vulnerable to breakdowns at scales, both colossal and minuscule. The universe is not only dynamic, but precarious, and the stability we take for granted is maintained only by the unbroken coherence of space and time. There is also a philosophical dimension to consider. If time itself can halt where space vanishes, then the end of the universe is no longer a story in the familiar sense. It is not a conclusion with consequences or a finale with resolution. It is a cessation of narrative itself, a silence deeper than anything humans can imagine. Our notions of before and after beginning and end would lose all applicability. We think of time as the stage on which life and events unfold, but if the stage disappears, so too does the performance, leaving only the shadow of what once was. This perspective also challenges the human instinct to project forward, to imagine survival or continuity. Scientific foresight, technological planning, even the speculation of cosmologists presupposes a flow of time that can be extrapolated. But if space and time are fundamentally fragile, then no extrapolation is guaranteed. The ultimate future of the cosmos is not a trajectory to map, but a question of stability. Will the scaffolding of existence hold, or will it collapse, stopping all motion and history in a manner we cannot anticipate? The awareness of this possibility is humbling, forcing a confrontation with the limits of knowledge and imagination. Even more disconcerting is the fact that such halts need not be uniform. If space-time fractures locally, there could be pockets of frozen reality islands of cessation, surrounded by regions still governed by temporal flow. In principle, one could imagine patches of universe where time has stopped, neighboring regions where it continues, creating a patchwork of existence and non-existence. The mind struggles to grasp such a scenario because every experience of time we have is continuous. How does one perceive or even conceive of a domain where causality no longer operates? The very act of reflection presupposes time, yet in these regions, reflection itself becomes impossible. Yet this contemplation is not purely despairing. It is also a testament to the richness and subtlety of the universe. The idea that time could halt reminds us that existence is not absolute, that continuity is a property contingent on the deeper structures of reality. It emphasizes the marvel that the cosmos has persisted for billions of years, maintaining its intricate dance of matter, energy, and causality, despite the underlying fragility of its framework. Each moment, each sequence of events is a triumph of coherence in a medium that by its nature is vulnerable. For us as conscious observers, the reflection is simultaneously humbling and inspiring. We inhabit a universe that might at any moment be poised on the edge of profound cessation, yet we are able to perceive, to contemplate, and to question. The fragile link between space and time is not only a source of potential vulnerability, but also a foundation for awareness. Our capacity to understand the contingency of existence is itself a product of the coherent flow of space-time, a fleeting privilege in a fragile cosmos. And this brings us to the next more troubling question. If space and time can cease, if the very scaffold of reality can unravel, then what lies beyond that cessation? Is there a beyond when time stops, a realm in which cause and effect no longer apply? Or is the cessation absolute, leaving no context, no framework, no possibility for existence as we understand it? To ask this is to confront the limits of both physics and imagination, a threshold where scientific inquiry meets philosophical mystery. It is here at the edge of cessation that we glimpse the deepest uncertainties of the cosmos, where questions of existence, reality, and the ultimate structure of space and time converge. In the heart of a black hole, the universe appears to break its own rules. These enigmatic objects formed from the collapse of massive stars are regions where gravity is so intense that nothing, not even light, can escape. But the most extraordinary feature lies deeper at the singularity, where our conventional understanding of space unravels completely. Here, space is not merely curved or stretched. It is torn, crushed, and contorted into a state that defies all physical intuition. In a very real sense, a black hole is a place where space itself has failed a laboratory of natural extremes that pushes the fabric of the cosmos to its limits. To grasp the peculiarity of a singularity, consider a familiar analogy. Imagine a sheet of rubber stretched taut representing the fabric of space. Place a heavy ball in its center, and the sheet dips, curving gracefully. Now increase the weight to a point beyond imagination. The sheet begins to tear, stretching thinner and thinner, until it cannot hold, ripping apart entirely. In a black hole, space is stretched in a comparable way, except the stakes are infinitely higher. The curvature becomes infinite. The mathematics of general relativity collapse, and the singularity forms a point where density and gravitational pull are effectively unbounded, and space-time ceases to behave in any familiar manner. What is most profound about black holes is that they suggest the universe can naturally create regions where space is fundamentally altered. Unlike theoretical constructs such as vacuum, metastability, or string ruptures, black holes are observable, existing in the cosmos as a tangible manifestation of space's fragility. We can detect their presence by the motion of nearby stars, by the X-rays emitted as matter spirals into oblivion, and more recently through the very waves in space-time caused by merging black holes. They are the universe's way of showing us that space, no matter how vast or seemingly eternal, can fail under extreme conditions. But the implications reach even further. Some theorists propose that black holes may not simply destroy matter, but could also create new regions of space-time. The singularity might be connected to a baby universe, a separate cosmos budding off from the parent universe hidden from our observation. If this is possible, the tearing of space within a black hole is not purely destructive. It is also generative. The collapse that seems final from the outside could give rise to a new universe entirely governed by its own laws and constants, its own flow of time and structure of space. This transforms the narrative of space tearing from catastrophe into potential creation, reframing destruction as an intrinsic part of cosmic evolution. The singularity challenges not only physical theory, but also philosophical understanding. In the depths of a black hole, the distinctions we make between here and there, inside and outside, begin to dissolve. Causality, the linear chain of cause and effect that defines our experience, is strained to the breaking point. The familiar coordinates of space cease to function meaningfully, and time itself may be altered or even swallowed by the gravitational well. The singularity becomes a threshold, a domain where ordinary notions of reality lose their applicability, yet one that is fully part of the observable universe. Imagine too the ripple effect of these cosmic laboratories. If black holes can alter space so dramatically, if they can pinch and tear the fabric of reality, might our own universe itself be the product of such an event in another parent universe? This possibility, though speculative, is mathematically consistent in certain cosmological models. The idea that the cosmos we inhabit could have originated from a spatial rupture in another universe is both humbling and exhilarating. It suggests that space does not merely exist in isolation. It is connected across generations of universes, with tiers and singularities acting as conduits for creation. Even more striking is the scale at which black holes operate. the supermassive black holes anchoring galaxies millions or billions of times the mass of the Sun warp space over light years. They demonstrate that spatial failure is not limited to microscopic or quantum scales. It can occur across astronomical distances, influencing entire regions of the cosmos. If space can tear under such conditions, then the fragility we contemplate in theoretical models is not hypothetical. It is realized on scales both vast and observable, underscoring the inherent tension between the apparent stability of space and its susceptibility to disruption. And yet black holes are paradoxical. While they are regions where space is seemingly destroyed, they are also remarkably persistent. The event horizon, the boundary beyond which nothing escapes, creates a stable interface with the surrounding universe. Matter may disappear into the singularity, but the black hole endures its influence, extending across cosmic distances. In this sense, black holes embody the duality of space, fragile within, resilient, without, destructive and generative simultaneously. They remind us that cosmic phenomena often defy simple moral metaphors of creation versus annihilation, beauty versus terror. There is also a profound lesson for our understanding of physics. Black holes expose the limits of general relativity and highlight the necessity of a quantum theory of gravity. At the singularity, classical equations break down, forcing physicists to confront the unknown. What are the true rules of space under infinite curvature? How does matter behave when density approaches infinity? The study of black holes is therefore both a journey into extreme conditions and a probe of the boundaries of human knowledge, a natural experiment that cannot be replicated in any laboratory. Reflect for a moment on the paradoxical elegance of black holes. They are regions where space is torn beyond recognition, yet they anchor entire galaxies. They obliterate matter in their interior, yet they may seed new universes beyond. They defy understanding, yet they provide the clearest evidence that the cosmos is not a fixed stage, but a dynamic, evolving system subject to both fragility and renewal. In a very real sense, black holes are the universe's mirrors, reflecting both the potential for space to unravel and for creation to emerge from collapse. Ultimately, black holes suggest a new way of thinking about cosmic fragility. The tears, rips, and singularities within them are not merely threats. They are natural processes that reveal the underlying plasticity of space. If our universe itself was born from such a rupture, then the concept of spatial failure need not be purely negative. It may be part of an ongoing cycle, a mechanism by which universes evolve, emerge, and transform. In contemplating the tearing of space within black holes, we are glimpsing both the vulnerability and the creativity embedded in the cosmos. And so we arrive at a paradoxical understanding: the places where space has failed the most spectacularly may also be the very sites where new cosmic beginnings are seeded. If black holes can give rise to universes, then the tearing of space is not merely an end, it is a form of cosmic rebirth. And in that rebirth we find a subtle reassurance. Even the most violent fractures in the fabric of reality may carry within them the potential for new structures, new spaces, and perhaps new forms of life, yet unimagined. The story of space tearing is thus not just a tale of fragility and loss, it is also a story of resilience, creativity, and the profound, often paradoxical nature of the cosmos. Imagine for a moment that the universe is not a spontaneous occurrence of matter and energy, but a carefully coded simulation, a vast digital construct running on principles we barely grasp. This is the bold premise of the simulation hypothesis, which proposes that reality itself might be generated by an underlying computational framework, a grid of discrete points, akin to pixels on a screen. In such a scenario, space is not infinitely divisible, but quantized, a lattice of fundamental units, forming the continuum we perceive as smooth and unbroken. At ordinary scales, this lattice is imperceptible, giving the impression of seamless space-time. Yet at extremes near black holes in the first moments of the universe, or in hypothetical scenarios of spatial rupture, the limitations of this resolution could manifest as anomalies, discontinuities, or what we might interpret as cracks in the fabric of space itself. Visualize a digital image on your computer. From a distance, it appears flawless, the lines smooth, the colors continuous. But as you zoom in ever closer, individual pixels become apparent, the illusion of continuity breaks down, and the image resolves into discrete units. In the same way, if the universe operates on a finite lattice or computational grid, the apparent smoothness of space is only a convenient approximation. When stressed by extreme energy, cosmic expansion, or hypothetical tears, the underlying discreteness could manifest as what physicists and philosophers interpret as spatial anomalies. What looks like the fracturing of space could, in this view, be the universe revealing the constraints of its own code. This perspective has profound implications for our understanding of cosmic fragility. Traditionally, tears or rifts in space are conceived as physical phenomena, consequences of energy expansion or exotic fields. In a simulation framework, however, they could be entirely epistemological, a failure of the system to render reality with infinite precision. The cracks are not the collapse of matter or the unraveling of dimensions, but artifacts of computational limitation. A reminder that the universe might be operating on rules beyond direct perception. Our laws of physics, the constants we measure, the apparent smoothness of space-time, all of these could be emergent properties of a deeper algorithm. The notion of a simulated cosmos also reshapes the stakes of cosmic repair and fragility. If the universe is coded, then cracks might be correctable, glitches might be patched, and what seems like destruction might be reversible at the level of programming. This is a radical shift from the conventional narrative of inevitable collapse or entropy. The universe might be more resilient than it appears, its apparent vulnerabilities contingent on the fidelity and maintenance of the underlying code. In this light, cosmic phenomena such as black holes, vacuum, instability, or even big rip scenarios could be interpreted as stress tests on the system, moments where the simulation's resolution is pushed to its limits. Consider the implications for observation and measurement. If reality is discretized, then all instruments, all observations are interacting with a lattice, a grid, or a code. The anomalies we detect, the quantum foam, the limits of precision in measuring space-time, the apparent non-continuity at Planck scales, might be evidence of the pixelated structure beneath the surface. The uncertainty, randomness, or probabilistic nature of quantum mechanics could be interpreted as the system interpolating between discrete points, maintaining continuity while never fully achieving it. What we perceive as inherent indeterminacy could be an artifact of the resolution of the simulation. There is also a philosophical resonance. The idea that the universe might be a simulation challenges our deepest assumptions about existence, causality, and agency. If space is coded, if what we perceive as physical laws are emergent algorithms, then the cracks in reality are not cosmic accidents, but features of a system with an author or origin. The question of fragility becomes intertwined with the question of authorship. Is there an intelligence maintaining the system, correcting glitches, or allowing errors to propagate? If cracks can exist, then the universe is not only contingent on physical laws, but potentially contingent on the intentions or limitations of a programmer. This hypothesis also redefines the nature of cosmic danger. Traditional threats, energy collapses, singularities, vacuum decay are framed as unavoidable consequences of physical processes. In a simulation framework, the universe's end might resemble a software crash or a system reboot. The destruction would not be chaotic but programmatic, a cessation dictated by computational parameters. Conversely, what seems like catastrophic instability could be corrected algorithmically, suggesting a resilience that is both alien and comforting. The universe might be self-healing at levels invisible to us, or its fragility might be contingent on higher-order rules beyond our comprehension. Imagine, too, the narrative possibilities. In a universe governed by code, the cracks, the singularities, and the fractures are like debugging logs, moments where the system signals the limits of its resolution. Observing and interpreting these anomalies becomes a way of understanding the rules of the simulation. Each ripple in space-time, Each deviation from expected behavior could be a clue to the architecture underlying reality. In a sense, physicists become explorers of code, archaeologists of algorithms, deciphering the deep structure of existence, not through intuition alone, but through careful measurement and inference. There is a striking tension in this picture between fragility and design. On one hand, discrete spacetime imposes a limit, a vulnerability, an inherent constraint on continuity. On the other hand, coding implies intention and potential control. Fragile phenomena, such as rifts, could be understood not as fatal failures, but as manageable imperfections within a system designed to sustain complex processes over cosmic timescales. The cracks are thus both warnings and guides, indicators of limits, but also pathways to understanding if one can decipher the rules behind them. Pause and reflect on that. The universe in this view may be a grand construct pixelated and coded with rifts that signal the boundaries of resolution. What appears as catastrophic tearing of space might in reality be a visual hint of computational structure, a window into the machinery of existence itself. This does not diminish the awe-inspiring complexity of the cosmos. Rather, it amplifies it. Even glitches, even anomalies are expressions of the subtle and intricate architecture sustaining all that is. And then arises the most provocative question. If the universe is a simulation, and cracks are artifacts of code, then is there a programmer? Could there be an entity or intelligence capable of correcting, modifying, or repairing these cosmic glitches? And if so, what would their interventions look like to us, the inhabitants of the simulation? Would phenomena we perceive as miracles, quantum events, or cosmological coincidences be hints of maintenance, debugging, or optimization occurring beyond the veil of perception? The notion challenges the boundary between physics and philosophy, between natural law and intentional design, and forces us to reconsider what fragility truly means. Ultimately, viewing the universe as a potential simulation reframes every crack, every tear, every rift in space as a feature as much as a flaw. The fragility of the cosmos is not simply a matter of physical vulnerability. It may be an expression of a structured, coded system with rules, limitations, and perhaps even guardianship. The very cracks that terrify us in theories of spatial collapse could simultaneously be windows into the architecture of reality, offering insight into a universe more intricate, more controlled, and more wondrous than any unbroken continuum could convey. And so we arrive at a quiet, almost unsettling contemplation. What we perceive as the tearing of space might not be a fundamental catastrophe at all. It could be a subtle signal, a gentle imperfection in the code of existence, reminding us that the universe is both delicate and designed, constrained, and yet astonishingly vast, a simulation or reality whose rules we are only beginning to perceive. The cracks, then, are not merely the end of things. They are the universe whispering its structure, inviting us to listen, to explore, and to wonder. The notion of space breaking is not only a scientific hypothesis, but also a philosophical mirror reflecting our deepest questions about existence. From ancient times, thinkers have grappled with the tension between the finite and the infinite, between order and chaos, between the tangible world we inhabit and the boundless realms we can only imagine. The idea that space itself might fracture, tear, or dissolve forces us to confront these same questions anew. It challenges our assumptions about permanence, stability, and the continuity of reality. And yet, in confronting this fragility, there is also an invitation to explore transformation. Could the breaking of space be not merely a catastrophe, but a transition to something profoundly different, something beyond ordinary comprehension? Consider the ancient philosophical reflections on finitude. The Greeks, for instance, debated the limits of the cosmos and the nature of being. Aristotle pondered the infinite, the notion of an unbounded expanse that could stretch endlessly in all directions, while the Stoics reflected on cycles of creation and destruction, emphasizing that even seeming endings could be beginnings in another form. These philosophical traditions recognize that apparent rupture or dissolution is not inherently negative. It may signify a passage, a reconfiguration, a transformation into a new state. The breaking of space then might echo these perennial questions: what is the meaning of limits and what lies beyond them? Modern philosophy extends these reflections into the context of cosmic fragility. If space can fracture, then the universe is not a static eternal edifice, but a dynamic contingent entity, subject to processes of transformation at scales both immense and subtle. A rupture in the cosmic fabric might signal an end to one kind of reality while simultaneously opening the possibility of another. This is a deeply unsettling idea because it defies our ordinary understanding of continuity. Yet, it is also liberating because it suggests that endings are not absolute annihilations. They are thresholds to new forms of existence. In this sense, the fragility of space can be seen as a bridge linking the cosmos we inhabit to realities beyond our perception, inviting us to rethink the nature of existence itself. There is a subtle paradox embedded in this reflection. On one hand, the notion of space breaking evokes terror. It implies the dissolution of the stage on which all matter, energy, and life operate. Time itself may halt. Causality could become meaningless. The universe could cease in ways incomprehensible to human minds. On the other hand, the very concept of rupture implies potential. Breaking is a transition. It is the opening of possibility. Philosophers have long argued that what appears destructive can be generative. Just as a seed must split to grow the cosmos, if it fractures may be in the process of generating structures or dimensions we cannot yet imagine. The anxiety of cosmic fragility is inseparable from the wonder of its transformative potential. This perspective also resonates with ideas from Eastern philosophy. Concepts such as impermanence and transformation in Buddhist thought, or the cyclical nature of creation and destruction in Hindu cosmology, suggest that what appears to be an end is in fact a moment within a larger continuum. A fracture in space is not merely a cessation, but a pivot point, a moment when the familiar yields to the unknown. It encourages a contemplative approach, a meditation on the transitory nature of reality, and a recognition that stability is always provisional. In this light, the universe's fragility is not a flaw, but a feature, a manifestation of the deeper principles that govern existence. There is also an ethical and existential dimension to this contemplation. Recognizing the universe's vulnerability invites humility. As small conscious beings embedded within a fragile cosmos, we are reminded of our dependence on structures far beyond our control. Yet this awareness need not breed despair. It can inspire careful stewardship of what we can influence, an appreciation for the ephemeral beauty of existence, and a sense of participation in a universe that is dynamic and ever-changing. Understanding the fragility of space can deepen our gratitude for each moment, each observation, and each insight into the workings of the cosmos. The philosophical implications extend further. If breaking is a form of transformation, then human experience itself can be interpreted through this lens. Just as space may fracture and reconstitute, so too can our understanding, our societies, and our knowledge. Crises, ruptures, and moments of disruption in human life may mirror cosmic processes on a smaller scale, revealing that the universe's fragility is reflected in the patterns of experience, thought, and growth. There is a poetic symmetry here. The macrocosm and the microcosm resonate, and the breaking of space becomes a metaphor for the continual cycles of loss and renewal that define existence at all scales. Moreover, contemplating the philosophical dimension of space breaking allows a shift from fear to curiosity. Instead of focusing solely on what might be lost, one can consider what might be discovered. Fractures in space, theoretical though they may be, push us to imagine new forms of physics, new frameworks of understanding, and new ways of relating to reality. The mind is challenged to transcend conventional constraints, to speculate on dimensions, processes, and states of being far removed from everyday perception. Fragility thus becomes a catalyst for exploration, a prompt to expand the boundaries of imagination and inquiry. There is finally a meditative quality to this reflection. When one contemplates the breaking of space, it is possible to dwell in a space of awe and uncertainty, allowing the mind to consider the vast unknown without immediate anxiety. Philosophical inquiry into cosmic fragility cultivates patience, attention, and openness to ambiguity. It encourages the practice of stepping back from the immediate and the familiar, and considering the deep architecture of reality with a mixture of wonder and humility. In this sense, the universe's potential for rupture becomes a tool for intellectual and spiritual enrichment, a prompt to embrace the vastness and mystery of existence. And yet this contemplation naturally leads to a pressing question. If space truly fractures, what can we, the small ephemeral beings inhabiting this cosmos, do? We are not omnipotent. We cannot mend the fabric of reality. But reflection, understanding, and imagination become forms of participation. By exploring the fragility of space, by grappling with the possibility of rupture and transformation, we extend consciousness into domains that are otherwise inaccessible. Even in our smallness, we contribute to the awareness of the cosmos, bearing witness to its vulnerabilities, marvels, and mysteries. Ultimately, the philosophical reflection on broken space invites a dual stance. It acknowledges the terror of potential endings, while simultaneously opening the mind to transformation, to possibility, and to wonder. It teaches that fragility is not merely a threat, but also a doorway to insight, contemplation, and perhaps even meaning. The universe, when viewed through this lens, is a living interplay of risk and creativity, of rupture and renewal, and of endings that are also beginnings. In considering the fractures of space, we are invited not only to confront the fragility of the cosmos, but to embrace the vast, mysterious continuum of existence itself, understanding that in every potential rupture lies the possibility of an age A2, entirely new horizon. Throughout human history, civilizations have faced apocalyptic visions, whether literal or symbolic. Plagues, wars, environmental collapse, and cosmic anxieties have shadowed societies, yet in the midst of uncertainty, humans have continued to create, to explore, and to love. Art has flourished, science has advanced, and communities have formed even under the looming specter of potential annihilation. There is a remarkable resilience in the human spirit, a capacity to find meaning and purpose despite the fragility of the world, or in our cosmic context, the fragility of space itself. This perspective shifts the narrative from fear of destruction to recognition of our engagement with existence, reminding us that the significance of our actions is not nullified by the vast unknown. Even if space were to fracture, even if the universe's fabric were to tear or dissolve, the experiences and awareness of conscious beings retain value. The paintings, music, mathematical discoveries, and stories of humanity do not cease to exist in meaning simply because the stage on which they unfold is impermanent. Meaning is not contingent solely on external permanence. It emerges from engagement, reflection, and relational experience. Just as we find joy in a sunrise, even knowing it will end, we find significance in knowledge, beauty, and connection, even amidst the possibility of cosmic instability. The fragility of space thus heightens, rather than diminishes, the value of lived experience. Consider the arts, for instance. The music composed under times of turmoil, the literature written during wars, the paintings created under duress, all testify to the human drive to express and understand. These endeavors occur in the shadow of uncertainty, yet their impact endures, carried not only through time but through the consciousness they touch. If the universe itself were fractured, our acts of creation would not vanish from significance. They would remain as expressions of awareness and intentionality, markers of our presence in a cosmos that is neither permanent nor guaranteed. Space's fragility reframes creation as a courageous affirmation of existence, rather than a futile gesture against inevitability. Science, too, reflects this resilient engagement. Observing, measuring, theorizing, these acts of inquiry are human attempts to render the universe intelligible, to engage with the cosmos despite its immense scale, and potential instability. Discoveries about black holes, dark energy, and the structure of space-time emerge from curiosity and rigorous investigation. Even if the cosmos were to change or collapse in ways beyond prediction, the process of exploration and understanding remains meaningful. Each observation, each calculation, each theoretical insight is a testimony to human consciousness, interfacing with reality, asserting comprehension and awareness in the face of potential impermanence. There is also a profoundly human response to uncertainty that extends beyond creation and discovery. The capacity to form relationships, to love, to care, to empathize, and to communicate imbues life with richness that persists even under existential threat. Bonds forged in the knowledge of impermanence take on heightened significance. If space is fragile, if the universe may alter or cease in ways unimaginable, the immediacy of human connection becomes a source of grounding and meaning. Shared experiences, compassion, and care are not negated by cosmic fragility. They are illuminated by it, offering stability and significance in a universe that may be otherwise unstable. In a sense, the fragility of space functions as a magnifying lens for human consciousness. When confronted with potential cosmic rupture, we are reminded of the temporality and preciousness of experience. Every act of perception, reflection, creation, or connection becomes amplified, imbued with a deeper resonance precisely because the background of existence is not guaranteed. This awareness does not necessitate despair. Rather, it can cultivate appreciation, mindfulness, and intentionality. The universe's vulnerability reframes human action as significant, compelling us to live fully within the moments available to us. There is also a subtle humility embedded in this reflection. Recognizing the impermanence of space and the fragility of existence highlights the limitations of human power. We cannot control cosmic dynamics, prevent potential rips in space-time, or dictate the ultimate fate of the universe. Yet within these limitations lies freedom. The freedom to choose how we engage with the present, to invest in understanding, connection, and creativity. Awareness of fragility does not paralyze. It empowers thoughtful participation. Humans may be small, ephemeral beings in a vast and vulnerable cosmos, but consciousness and intentionality are forms of engagement that assert presence and significance against the backdrop of uncertainty. The perspective of human experience also invites a reconsideration of legacy and memory. While space may be impermanent, the traces we leave through thought, art, knowledge, and relationships constitute patterns that persist in meaning, if not physically. Stories told, knowledge shared, and emotions expressed create networks of influence that extend beyond individual lifespan and immediate spatial context. In contemplating the universe's potential fragility, the act of leaving such traces becomes a form of existential dialogue, a way of asserting coherence and presence within a cosmos that may itself be unstable. Even contemplation itself acquires value. The very act of pondering cosmic fragility, of engaging with the possibility of space tearing or of time ceasing, is a uniquely human response. It demonstrates an awareness of the vastness and complexity of reality, a capacity for reflection that transcends immediate survival or comfort. Such contemplation does not prevent cosmic events, yet it situates consciousness within the broader narrative of the universe, allowing human beings to participate meaningfully in understanding, imagination, and inquiry. In this sense, awareness is itself a form of resilience, a way to affirm presence in a fragile cosmos. Ultimately, the human perspective offers a counterbalance to cosmic fragility. While space may tear, dark energy may accelerate expansion, and singularities may form the human engagement with reality through creation. Understanding, connection, and reflection retains irreducible value. Fragility is not the same as futility. The transience of cosmic structures amplifies the significance of conscious experience, reminding us that meaning arises not solely from permanence, but from engagement, awareness, and the intentionality with which life is lived. And so, when confronting the potential fracturing of space, Humans are left with a choice to succumb to despair in the face of vulnerability, or to embrace existence fully with curiosity, creativity, and compassion. The fragility of the universe becomes a call to presence, an invitation to act and reflect in ways that affirm life consciousness and the beauty of experience. Even if the cosmic stage is impermanent, the performance, the dance of understanding, feeling, and creation retains significance. In this light, the view of humanity within a fragile cosmos is profoundly empowering. We are reminded that value and meaning do not depend solely on the endurance of the universe, but on the depth of our engagement with it. Even in a universe that may fracture, that may expand without limit, or that may someday cease, the human capacity to observe, to think, to feel, and to act remains a beacon of significance. Fragility is a reminder to cherish awareness, to deepen understanding, and to live intentionally affirming existence moment by moment. And this perspective naturally leads to a conclusion not focused on cosmic destruction, but on human experience itself. The story of space tearing, of singularities, of energy and expansion becomes not merely a narrative of fragility, but a mirror reflecting the resilience, creativity, and awareness of those who inhabit it. It teaches that meaning is forged in the interplay between vulnerability and engagement, and that even in a cosmos that may fracture, the conscious observer has the power to perceive, to create, and to find significance. In the end, the contemplation of cosmic fragility is inseparable from the contemplation of what it means to be alive, aware, and human. Imagine the universe as a grand symphony stretching across eons. Each galaxy, each star, each particle contributing its note to a cosmic melody that has been playing since the dawn of time. It is a music so vast that human ears cannot hear it, so intricate that human minds can barely begin to grasp it. And yet, in its unfolding, there is a rhythm, a structure, a harmony that binds the cosmos together. This is the music of existence itself, a continuous composition that has played without pause, until perhaps the day comes when space itself begins to fracture the strings of reality, trembling, the resonance fading. It is tempting to imagine that in such a moment the universe would not end with silence abruptly, but with a final lingering note, a fading chord that marks the culmination of cosmic history, a last echo of the symphony that once filled all. In poetic terms, one might picture this star's dissolving galaxies, stretching and tearing, atomic bonds fraying, yet even as all structure falls away, there is a sense of continuity in the music of existence, a memory of the harmony that was a testament to the beauty that emerged from the fundamental laws and interactions that governed reality. We, as conscious beings, stand as witnesses to this spectacle, not architects of its unfolding, yet participants in the awareness of its grandeur. It is a humbling position, and yet a profoundly enriching one, for it allows us to experience and reflect upon the cosmic performance, even as it approaches its potential end. Consider the multiplicity of scenarios that physicists contemplate: the slow, inexorable expansion tearing the cosmos apart in a big rip, the subtle decay of vacuum metastability, sending a bubble of alternate reality rushing through space, the quiet dissolution of quantum fluctuations across a vast multiverse. Each scenario represents a different ending, a distinct cadence in the universal symphony. Yet in each, the role of human observation is the same. We are the audience, absorbing, interpreting, and finding meaning. Even as the score approaches its final notes, the act of listening, of witnessing, imbues the moment with significance that transcends the mechanics of physical processes. There is an intimate beauty in this position. Humanity does not need to control the universe to appreciate its magnificence. In the same way that we can be moved by a piece of music, aware that it was composed and performed by forces outside our control, so too can we be moved by the unfolding of the cosmos. The potential cracking of space does not diminish the value of our attention. If anything, it magnifies it. Each moment of awareness, each act of contemplation, each insight into the workings of reality becomes a note in our own experience of the universal composition. a personal resonance within the vast orchestra of existence. This perspective encourages a shift in focus from fear to presence. It is natural to react to cosmic fragility with anxiety, to envision endings as catastrophes that nullify meaning. Yet the metaphor of music reframes the experience. Even a fading note, even a dissolving chord, has intrinsic value, evokes emotion, and communicates something profound about the nature of being. The universe, in all its potential instability, continues to offer a canvas upon which human consciousness can paint understanding, wonder, and reflection. Our engagement with the cosmos is itself a kind of music, a counterpoint to the grander symphony, harmonizing in ways that are uniquely human. Furthermore, this contemplation invites us to consider the temporal dimension of experience. While the universe may outlast or outpace our lifespans, our awareness exists within a fleeting interval. Yet it is within this interval that perception, thought, and imagination occur, and it is precisely this temporality that gives our experience poignancy. The potential end of space is not only a scientific curiosity, but a reminder of the preciousness of the present moment. To witness, to reflect, and to imagine within the universe's fleeting stability is to participate fully in the cosmic symphony, to listen attentively to the notes as they play, to feel the resonance even as it fades. One can also draw a philosophical lesson from this metaphor. The fragility of space does not negate the persistence of human imagination, curiosity, and creativity. Even if the physical substrate of reality ultimately dissolves, the acts of questioning, exploring, and imagining leave traces in consciousness, in memory, in the collective narrative of sentient life. These traces are, in a sense, more enduring than matter itself. Stars may burn out, galaxies may disperse, but the awareness of observers, the insights gleaned, and the stories told constitute a continuity of understanding that survives beyond immediate physical stability. The music of the universe may end, but the human response, the interpretation, the reflection, the emotional resonance carries forward, echoing in ways both subtle and profound. This invites a contemplative humility. As participants in the cosmic performance, we recognize the limits of our control. We cannot prevent the symphony from fading nor dictate the final notes. Yet this acknowledgement does not diminish our significance. It amplifies the importance of presence, of attentive engagement, and of conscious participation. The ultimate beauty of the universe may lie not only in its physical structures, but in the act of being aware of them, in the capacity to witness, to feel, and to reflect. Human consciousness becomes both a lens and an instrument attuned to the harmonics of reality, responsive to its cadences, and capable of finding meaning even in transience. In practical terms, this perspective reframes how one might approach the cosmos. Rather than focusing solely on potential catastrophe, we are invited to cultivate appreciation, curiosity, and active engagement, to observe the night sky, to study celestial phenomena, to contemplate the underlying principles of physics and cosmology, is to participate in the music. Each act of understanding, each moment of reflection, each feeling of awe, is a contribution to the ongoing resonance of experience, a counterpoint to the impermanence of matter and space. There is also a poetic solace in recognizing that the universe's end, however it unfolds, is a culmination rather than a negation. A final chord in the cosmic symphony is not nothingness. It is a conclusion, a release, a transition from one state of being to another, even if that state is unknowable to us. In witnessing and contemplating this, humans achieve a form of transcendence. The act of understanding, of listening, of imagining becomes a bridge, connecting finite awareness to the infinite scope of existence. In this sense, fragility is inseparable from beauty, impermanence inseparable from meaning. And so the audience remains mindful and attentive, not as controllers of the symphony, but as participants in its reception. The potential cracking of space, the dissolution of matter, the ultimate fading of cosmic structures do not render the human role meaningless. Rather, they accentuate the preciousness of observation, the depth of imagination, and the resilience of curiosity. Each thought, each insight, each experience resonates against the backdrop of cosmic impermanence, creating a subtle harmony that outlasts the physical notes themselves. Ultimately, the final music of the universe, whether it fades slowly, tears violently, or resolves into silence, is a reminder that existence is experienced, interpreted, and enriched through consciousness. It teaches that fragility does not negate significance, and that endings are inseparable from the process of engagement, reflection, and imagination. The true lasting note may not belong to the cosmos itself, but to those who listen, who question, and who dream within it. And so, as the cosmic symphony approaches its final cadence, the lesson is clear. Space may fracture, stars may die, galaxies may unravel, yet the human capacity for wonder, for curiosity, and for imagination persists. It is the enduring echo of our consciousness that may outlast even the stars, the lingering note in the music of existence that affirms life perception and the infinite potential of thought. Space may break, but the human mind, attuned to the harmony of the cosmos, will continue to listen, to imagine, and to find meaning long after the last physical chord has faded.